Determining the truth values of statements. Determining the truth values of statements. Every statement has its own truth value, and you will not be able to determine the truth value of a statement unless you have the knowledge of the truth values of logical connectives, which we've already established or tried to explain using the truth table. For the logical connectives, we have the conjunction, the disjunction, the conditional, the biconditional, and the negation. They all have their truth values. And we must have knowledge of these truth values because that is what will guide our analysis in this topic. So anyone who does not have knowledge of the truth values of logical connectives cannot do business with us. That individual will not be able to do anything in this topic. So, knowledge of the truth values of logical connectives is very important. We said that a conjunction is true when both conjuncts are true. Any other condition is false. A disjunction is false when both disjuncts are false. Any other condition is true. A conditional statement is false when the antecedent is true and the consequent is false. Any other condition is true. A biconditional statement is true when the components have equal values, which means that when they are both true, then it's true. When they are both false, then it's true. A biconditional statement is only false when the components do not have equal truth values. When one is true and the other one is false, then it's false. But when they are both true, it's true. When they are both false, it's true. And for negation, we already know that when a true statement is negated, it becomes false. And when a false statement is negated, it becomes true. So this knowledge is very important. Let's take note of this. Here, we'll be dealing with statements. We want to know the truth value of statements. But you must understand that simple statements come together to form compound statements. And even simple statement can be joined with compound statement to form complex ones. Or compound statements can come together to form more complex statements. But all the same, no matter how complex it is a statement is a statement. And that statement, no matter how complex, will have its own truth value. But how do you determine the truth value of such a statement then if it is complex? How do you do that? Now, let me make this explanation. Take a look at this. You have y wedge z in this parenthesis, wedge b dot m in this parenthesis. So this y is a simple statement. Y here is a simple statement. Z is another simple statement. Y and Z have been brought together with the aid of this logical connective. So two simple statements have come together now to form a compound statement. And we have them in this parenthesis. When you come here, we have another simple statement, B dot M. This is one simple statement and this is another simple statement. They'll be brought together with the aid of a conjunction. And then we have B dot M. Two simple statements have been able to come together to form a compound statement. Now, we have one compound statement here and another compound statement here, joined with the wedge. Joined with the wedge, forming a complex statement. And you could have statements that are even more complex than this. So, Y wedge Z coming together with the aid of a disjunction. So, Y will have its own value. YZ will have its own value. whether true or false or true or false. Then, with your knowledge of logical connective, you should be able to combine y and z to know the value of this wedge. So, the value of this wedge would therefore be the value of this parenthesis. And then, the value of this dot would therefore be the value of this parenthesis. You know, you can only get the value of this dot with the aid of, by combining b and m, the value of b and the value of m to get this. So now this parenthesis has been joined with this parenthesis with this, with the aid of this disjunction. So to get this, the value of this disjunction, you have to combine the value of this parenthesis, which is the value of this wedge, and the value of this parenthesis, which is the value of this dot, to get this. When you succeed in getting the value of this wedge, you have been able to get the value of the entire expression, which is covered with the brackets. So this wedge is therefore the value of the entire expression here, not this and not this, because this is just the value for this parenthesis and this is the value for this parenthesis. This is the value of the whole of this bracket, which is the entire expression. Take a look at this as well. Here we have y wedge z in this parenthesis, and then we have b dot m in this parenthesis, joined with this wedge, all in this bracket, covered within the scope of this bracket. Mind you, another statement has been joined with this bracket, with the entire bracket, dot a, covered by the braces, So which means that everything in this bracket is one statement joined with this a, which is one statement on its own. Now, to know the entire value of the whole of this expression, you must know the value of this dot, because it is this dot that connects everything here and this. Just as this wedge connects everything here and everything here. You see that? So when we are able to provide values for all this, we'll make a further explanation of what we have there. So, but it is important to note that the value of the major connective is determined by the relationship of the truth conditions of the simple statements and the truth values of the logical connectives involved in the statement. That's exactly what I just explained to us. You must have the knowledge of the truth values of logical connectives. That is the only way out. If you do not have the knowledge of the truth values of logical connectives, you cannot do business with us. So, attention must be given to the punctuations involved in the statement. This is because we start analyzing statements from inside out. That's it. And what do we mean by that? You begin from parentheses. When you are done with the parentheses, you go on to brackets. When you are done with the brackets, you now go on to the braces. That is inside out. You can begin to find the value of these dots now that connects everything here, which is the value of the braces. Before you come here to find the value of this and then the value of this, you will not be able to arrive at the correct answer. You may not even be able to analyze it. So you must begin from inside out. Now, usually, the values of individual statements involved in a compound statement will be provided, and you will be required to rely on your knowledge of the truth values of logical connectives to provide the truth value of an entire expression, which means that you will be given the value of statements such as y will have its own value, z will have its own value, b will have its own value, and you will be given these values. And then, relying on your knowledge of logical connectives, you provide value for the entire expression. That's exactly the point we are trying to make here. So let's take a look at the examples we have here. Given that A and B are true statements represented by T, while X and Y are false statements represented by F, determine which of the following statements are true and which of them are false. What this simply means is that anywhere you see A, it is true. Anywhere you see B, it is true. Anywhere you see x, it is false, and anywhere you see y, it is false. You have been given the values of the statements involved. So it is now your duty to provide the value of the entire expression with your knowledge of logical connectives. So we have A wedge X. We've been told that A is true and then X is false. You see, anywhere you see X, Y, you say false. Anywhere you see A, B, you say true. So you note that down because all this will guide you. Now let's begin with A wedge X. We've been told that A is true. So under A we say true. We've also been told that X is false. These values are given. So X is false. Now, having known the value of the simple statements involved in this expression, you can combine this, which is F, and this, which is true. X is false, A is true, to get this value. How do you do that? You now rely on your knowledge of logical connective. This is a logical connective, and it's a wedge, a disjunction. Remember, a disjunction is false when both disjuncts are false. It is only when A, which is a disjunct, the first disjunct is false, and then X, which is the second disjunct is false, that this will be false. So both disjuncts are not false. For that reason, the logical connective here is true. So the entire expression A wedge X is therefore what? True. Now, let's move on to the next. Negation A wedge X wedge negation X dot Y. Negation A wedge negation X dot Y. Negation A is false. Why? We have been told that A is true. If A is true, what will negation A be? Negation A will be false because when a true statement is negated, it becomes false. And when a false statement is negated, it becomes true. So if A is true, negation A will be false. If X is false, negation X will be true. If Y is false, then Y is false. Look at that, because it's not negated. So you begin with the parenthesis. You must resolve what you have here in this parenthesis before you move to the brackets. This is a value of the entire expression now, because this wedge is what connects negation A with the whole of this parenthesis. This is what connects everything here with this. So it is the value of this connective that is therefore the value of the entire expression. So begin with the parenthesis. Is a dot a conjunction? A conjunction is true when both conjuncts are true. Then you find out, are both conjuncts true? The first conjunct is true, but the second conjunct is not true, it's false. So both conjuncts are not true. Therefore, it is false. So this conjunction is therefore false. You combine the value of this now, which is the value of this parenthesis. This dot here is the value of this parenthesis, and it is false. You combine this with this negation A, which is false, to get this, because this is now the value of the whole bracket. This is the value. So it's a disjunction. The first disjunct is false. The second disjunct is also false because the whole of this parenthesis is false. So a disjunction is false when both disjuncts are false. This disjunct is false and this disjunct is false. So the value of this disjunction is therefore what? False. So the entire expression is false. When you come here, you have A wedge B in a parenthesis dot X wedge Y in a parenthesis. So it means that everything in this parenthesis is joined with this dot with everything in this parenthesis covered by this bracket, which is the value. So this is what connects everything here and everything here in this bracket. So it is value of this dot that is therefore the value of the entire expression. So we are told that A is true. We've been given those values already. A is true, B is true, X is false, and Y is false. You see that? Y is false. You can begin with any of the parentheses. You can start from here or you can start from here. You can only begin from parentheses. You can't come and start trying to determine the value of these dots now as your starting point. You can't. You must begin with the parentheses. If there's another parenthesis as we have here, you go on to resolve the value of this parenthesis and then you come to the whole of the brackets. So let's start from here. X is false, Y is false, because you can start from any of the parentheses, anyone. So X is false, Y is false is a disjunction. A disjunction is false when both disjuncts are false. Both disjuncts are false, therefore this is false. Take note of this value because this is not the value of this parenthesis. You are going to combine it with the value of this parenthesis. A is true, B is true. It's a disjunction. A disjunction is false when both disjuncts are false. Both disjuncts are not false, therefore it is true. So we now know the value of this parenthesis, which is true. You combine the value of this parenthesis with the value of this parenthesis. And it's a conjunction. A conjunction is only true when both conjuncts are true. So the first conjunct is true, the second conjunct is false. They are not both true, therefore it's false. When you take a look at this, we have A conditional bracket open, X logically equivalent to parenthesis open, B conditional Y, parenthesis close and bracket close. So if you take a look at this now, you see that B is joined with Y with this conditional sign in this parenthesis. Why everything here in this parenthesis have been joined with this X in this bracket, joined with this triple bar logical equivalence sign. And everything in this bracket is joined with this A, with this connective, conditional. So this is a major connective for the entire expression because this is what connects A and everything here. Everything here. So this is the major connective. So it is therefore the value of this that determines the value of the entire expression. So A is true, we've been told. X is false. And then B is true. Y is false. You start from parentheses, you go on to the brackets, and then to the braces, to the braces. So B conditional Y. B is true, Y is false. This is a conditional statement. A conditional statement is only false when the antecedent is true and the consequent is false. So the antecedent is true, the consequent is false, therefore this is false. That's why we put false here. This is not the value of this parenthesis. The value of this parenthesis is therefore false. You will combine the value of this parenthesis with the value of this X to get the value of this logical equivalence. Mind you, that is the value of this bracket. We are done with the parenthesis, which is false. We now go on to the brackets. So the bracket here, we have X, which is false, logical equivalent to this, the value of the entire parenthesis here. So since it's triple bar, logical equivalence, it is true when the components have equal values. When they are both true, it is true. When they are both false, it is true. It's only false when one is true and the other one is false. So since these components, the first component here is false, and the value of this parenthesis is false, they are both false. So the components have equal values, therefore it's true. This is now the value for the whole of these brackets. This is the value for the whole of these brackets, true, because this is what connects this and the whole of this. So you combine everything here with this to get this. It's a conditional sign. So we have A conditional everything here. A is true and everything here is true based on the value of the logical equivalence here that covers the whole of this bracket. So antecedent is true, consequent is true. It is true. A conditional statement is only false when the antecedent is true and the consequent is false. The consequent is not false. For that reason, it is true. So this expression is true. So take a look at this. We have this expression here. You must pay full attention here, probably because of the negations that we have all around it. Now, this is what happens. We say you begin from parentheses, you go on to brackets. This is the parentheses. When you are done, you go on to brackets. When you are done with the brackets, you now go on to the braces. But take note, A dot negation X in this parenthesis. But everything in this parenthesis has been negated. Look at this. This negation is within the scope. Everything here is within the scope of this negation. So which means that everything you have here is negated. So if the value of this dot is true, it will be negated here and it will be false. It therefore becomes false, which means the new value of this parenthesis will therefore be false, if that is what it is. So you combine the value of this negation with this negation A to get this dot. And then mind you, the value here is what will then be the value of the brackets. But this entire bracket has been negated, which means that if this dot is true, it will become false because it has been negated. This negation will therefore be the new value for these brackets. So you combine the value of this negation with this negation X to get this dot, such that whatever value you get for this dot, whether it is true, let's say false, if it is false, it has to be negated because everything in this parenthesis, this dot is the value for the whole parenthesis, for the whole expression here. This dot is what connects everything here. But this, if it is true, then you have to come here and say false because everything here has been negated. And if it is false, you have to come here and say true. You see that? So let's take a look at this. Look at the table now. Having plotted the table here, you begin with the parenthesis. Begin with the parenthesis. A is true. Negation X is true because X is false and then negation X is true. A is true, therefore negation A is false. X is false, therefore negation X is true. So you begin from here. A is true, negation X is true. This is a conjunction. It's a conjunction that joins them together. So a conjunction is true when both conjuncts are true. Since the first conjunct is true and the second conjunct is true, therefore the dot here, the conjunction here is true. This is now the value for this parenthesis. But like I said, this parenthesis has been negated. Look at that. Everything in this parenthesis has been negated. Since this parenthesis has been negated, and here we combine A and negation X to get true, it will be negated. It becomes false. This is therefore the new value. This is therefore the new value for this parenthesis. This parenthesis. So you combine it. This false here, which is the value, this negation, combine it with negation A to get this dot. We have false, the negation of this parenthesis is false, dot negation A, which is false. And this is a conjunction. A conjunction is only true when both conjuncts are true. This is false and this is false. For that reason, it is false. So this bracket is therefore false. This bracket is therefore false. Look at it here. This bracket here, everything here is false. But everything here within this bracket has been negated. So everything here within this bracket has been negated. Has been negated. So if this bracket is false, it will be negated. It becomes what? True. So everything in this bracket now is true. So you combine this negation here with negation X to get the value for the braces, which is this dot. So you have T dot negation S, which is T, that is true, dot negation X, which is also true. A conjunction is true when both conjuncts are true. So both conjuncts are true, therefore this braces, the value of the braces is true. Look at it. This dot is the value of this entire braces. But everything in this entire braces has been negated. You see that? So if this is true and it has been negated, it means that everything here in this entire braces will be negated. True becomes what? False. So this is therefore the value of the entire expression, because the entire expression has been negated and it becomes false, which means true becomes false. If this were to be false, it will become true. Now, like I said, the values of the individual statements will be given to you. Just like we said, A, B, true, X, Y, false. Fine. But there are instances where the values of some statements will not be given, and you'll be expected to provide answers to determine the value of the entire expression, even when you do not know the value or the values of some of the statements involved. You see that? You must pay attention. Now, take a look at this example. Given that A, B, C are true, they are true statements, while X, Y, Z are false statements, and M and O are unknown, you have to determine the value of the expressions or the statements that you'll be given. So it means that anywhere you see A, you say true. Anywhere you see B, you say true. Anywhere you see C, you say true. Anywhere you see X, Y, or Z, you say false. And anywhere you see M, N, O is unknown. You don't know it. Begin with this. We have A wedge C in parentheses, wedge X dot M in another parenthesis. They've been joined together. We have that everything here now. This whole parenthesis joined with this wedge. With this whole parenthesis is connected with this parenthesis with this wedge, a disjunction. So we are told that A is true, so A is true. C is true, therefore C is true. X is false, so X is false. M is unknown. M is unknown. Take note, we are told that M, N, O, they are unknown. We don't know them. So M is unknown. We don't know M. That you do not know the value of M does not mean that you won't be able to determine the value of the expression. Sometimes you will be able. So you have to start work. Begin from parentheses, and then you go to the next parenthesis. You can begin from anywhere. In fact, let's begin from here. Now, X is false, M is unknown. Is it possible for us to get the value of this dot? Of course. Now, this is a conjunction. A conjunction is true when both conjuncts are true. So we already know that the first conjunct is false. Even when we do not know the second conjuncts, we are able to say that this parenthesis is false, because a conjunction is true when both conjuncts are true. One of the conjuncts is already false, so it is therefore impossible for both conjuncts to be true. If a conjunction is only true when both conjuncts are true, and one of the conjuncts is already false, so both conjuncts can never be true again. For that reason, even when we do not know the second conjuncts, this will be false, because it can never be true. It is therefore what? False. So the value of this parenthesis is false. When you come here, this is a disjunction. It is the first disjunct is true, the second disjunct is true. A disjunction is false when both disjuncts are false. Both disjuncts are not false, therefore it is what? True. You combine the value of this parenthesis, which is this disjunction, and the value of this conjunction, which is for this parenthesis, which is false, to get this. This is a disjunction. A disjunction is false when both disjuncts are false. Both disjuncts are not false. For that reason, it is true. So this expression is therefore what? True. Even when we do not know the value of this, we are still able to determine the value of the entire expression. So take a look at this. A wedge C wedge B dot M. A is true, C is true, B is true, M is unknown. We don't know it. So is it possible for us to determine the value of this expression? We can begin from anywhere. We can either start from here or we start from here, because this is a parenthesis and this is another parenthesis. So let's start from here. We can start from anywhere. It's a disjunction. A disjunction is false when both disjuncts are false. Here, Both disjuncts are true. So it cannot be false. It is therefore what? True. So we know the value of this parenthesis now. Take note of it, which is true. Then we come here. It's a conjunction. A conjunction is true when both conjuncts are true. The first conjunct is true. We do not know the second conjunct. Is it possible for us to now determine the value of this conjunction, these dots? It's impossible. We can't. Because a conjunction is true when both conjuncts are true. The first conjunct is already true. So this may be either true or false. If this is true, then this will be, the value here will be true. If this is false, the value here will be false. You see that? So it becomes a problem. You are not certain, you are not sure of what will be the value of this dot. Unlike this, what we have here. This is a conjunction. It is true when both conjuncts are true. But one of the conjuncts is already false. So it is impossible for both conjuncts to be true again. So we're able to say that it is false. We're certain that this is false. But here we are not certain. Because this conjunct here is true. A conjunction is true when both conjuncts are true. The first conjunct is already true. So if the first conjunct is already true, we don't know whether this one is either true or false. So we are not certain. If this one is either true or false, it will affect the value of this. We will not be certain. We will not know whether this one is true or whether it is false. So for that reason, this value here is unknown. We don't know it. But the good thing is that this is not the value, this is not the major connective. This is not what determines the value of the entire expression. This is the value of the entire expression. If we are unable to determine the value of this wedge here, then the whole expression will be unknown. But mind you, this parenthesis is true, and this parenthesis is unknown. We don't know it. How is it then possible for us to determine the value of this wedge? This is a wedge, and it's a disjunction. A disjunction is false when both disjuncts are false. The first disjunct is true. So both disjuncts cannot be false again. Even when we don't know this, we know that this is true. Because a disjunction is false